the threshold where order becomes something else. Everything looks familiar right up to the edge. The rules still apply. The patterns still hold. Then, without warning, order becomes something different. To understand why systems suddenly change their nature, we need to focus on thresholds. Not dramatic events, not singular shocks, but quiet boundaries where behavior shifts. On one side of the threshold, systems are predictable. They respond proportionally. Inputs lead to expected outputs. Cause and effect feel tightly linked. On the other side, the same rules still exist, yet they produce entirely new outcomes. What changes is not the rule book, but which rules dominate. This matters because thresholds are everywhere. In physics, materials flex repeatedly until they suddenly fracture. In biology, populations expand steadily until resources can no longer support them and collapse follows. In societies, trust accumulates slowly until a single moment reveals it has already been exhausted. In organizations, processes scale smoothly until coordination costs overwhelm efficiency. Nothing changes all at once. Pressure builds gradually, invisibly, through accumulation rather than impact. At first, order feels stable. Small disturbances are absorbed. Corrections work as expected. The system returns to equilibrium after each disruption. Each recovery reinforces confidence that the structure is sound, resilient, and self-correcting. The system appears to validate its own design, encouraging deeper reliance on its rules and greater faith in its controls. But thresholds do not announce themselves. They are crossed through accumulation, not through drama. Stress adds up quietly. Density increases. Interactions multiply. Dependencies tighten. Feedback loops shorten. The system still looks orderly on the surface, but its options are narrowing. Degrees of freedom are being lost one by one, even as performance appears smooth and controlled. What makes this dangerous is continuity. There is no obvious signal marking the transition. The same actions are taken. The same rules are followed. The same metrics are monitored, yet their effects quietly transform. Responses that once restored balance begin subtly altering it instead. Corrections still occur, but they no longer return the system to the same state they did before. Recovery becomes partial. Equilibrium shifts without being acknowledged. Order does not vanish at the threshold. It mutates. And once that mutation begins, the system is no longer playing by the rules you recognize. As systems approach their thresholds, behavior often becomes deceptively calm. Fluctuations shrink. Variability decreases. Noise disappears. The system appears more orderly than ever. This is not health. It is constraint. The system is no longer flexible enough to explore alternatives, so it repeats the same narrow behaviors with increasing rigidity. Mathematically, this happens because degrees of freedom are being eliminated. Options disappear. Pathways close. The system is forced into narrower patterns of behavior. Small deviations are quickly corrected, not because the system is strong, but because it has lost the ability to tolerate deviation. Stability here is not resilience. It is confinement. This creates a powerful illusion. Performance metrics improve. Efficiency rises. Predictability increases. Observers interpret this as strength, maturity, or optimization. Leaders feel validated. Designers feel vindicated. In reality, the system is approaching a critical point where even tiny disturbances will matter disproportionately. The calm is not reassurance. It is a warning disguised as success. Near the threshold, cause and effect stretch apart. Responses lag. Corrections overshoot. Feedback loops tighten further. The system begins reacting to its own adjustments rather than to the original conditions. Control mechanisms turn inward, amplify internal dynamics instead of regulating external ones. This is why warning signs are missed. The indicators people watch often improve right up until the transition. Volatility, which once signaled danger, disappears. Variability collapses. Deviations are crushed quickly. The calm feels earned. But mathematically, it signals imminent change. Silence replaces signal. Smoothness replaces adaptability. Thresholds do not feel dramatic from inside the system. They feel quiet, controlled, and irreversible. The conflict erupts only after the threshold is crossed and the system's behavior no longer matches its intentions. Actions meant to restore order now accelerate disorder. Efforts to stabilize create oscillations instead of balance. Controls produce feedback storms. The same inputs now generate unfamiliar outputs, and familiar solutions suddenly fail. This is the emotional peak. Not shock, but disbelief. The realization that nothing obviously changed, yet everything behaves differently. The system has entered a new regime. Experience no longer applies. Expertise feels outdated. Confidence becomes a liability rather than an asset. People try harder, not realizing effort now accelerates instability. Mathematically, this is a phase transition. The underlying rules have not changed, but dominance has shifted. Feedback loops that were once secondary take control. Nonlinear effects overwhelm linear reasoning. Small causes trigger disproportionate responses. Prediction collapses not because knowledge is lacking, but because the system itself now behaves differently. At this stage, intervention becomes risky. Too much force pushes the system further from equilibrium. Too little allows runaway dynamics to take over. There is no safe middle ground. The window for gentle correction closed at the threshold, long before the change became visible. What remains are trade-offs between different kinds of failure. What makes this moment so destructive is delay. By the time the transition is recognized, it has already happened. Observers respond to the past while the system operates under new rules. Policies, corrections, and expectations all lag behind reality. Efforts target a system that no longer exists. The conflict is not failure versus success. It is expectation versus reality. And reality has already moved on. The resolution comes when order is no longer treated as a fixed state, but as a phase. Systems can be stable, unstable, or something in between. Each phase has its own behavior, its own risks, and its own rules of survival. Stability is not permanent. It is conditional, temporary, and dependent on context. Mathematics shows that thresholds are not enemies. They are transitions, points where old structures can no longer support accumulated pressure. When anticipated, thresholds allow adaptation. When ignored, they force collapse. The difference lies not in the threshold itself, but in whether it is recognized in time. Designing with thresholds in mind changes priorities. Instead of preventing change, systems are built to shift gracefully. Flexibility is preserved. Redundancy is valued. Diversity is protected. Early signals are monitored. Movement is allowed before rigidity takes hold. Failure is permitted in small, controlled ways to avoid total breakdown. The deeper lesson is humility. Order is temporary. Predictability is conditional. Stability is not owned. It is earned continuously through attention, adjustment, and restraint. Every system carries the seeds of its own transformation, not as a flaw, but as a natural consequence of accumulation. Every system reaches a threshold. What happens next depends on whether that moment is recognized in time or dismissed as noise until it becomes irreversible. Sometimes the smallest shift in perspective becomes the beginning of a new future. The